Relative masses of individual atoms can be determined by using a mass spectrometer. Gaseous atoms or molecules at very low pressures are ionized by removing one or more electrons. The cations formed are accelerated by a potential of 500 to 2000 volts towards a magnetic field which deflects the ions from their straight line path. The extent of the deflection is inversely related to the mass of the ions. By measuring the voltage required to bring two ions of different masses to the same point on the detector, it is possible to determine their relative masses. As it happens, natural occurring fluorine consists of a single isotope with an atomic mass of 19 AMUs. This situation for most elements is not the same. The situation with most elements is more complex because they occur in nature as a mixture of two or more isotopes. To determine the atomic mass of such an element, it is necessary to know not only the masses of the individual isotopes, but also their atom percent abundance in nature. Fortunately, isotope abundances, as well as isotope masses, can be determined by the mass spectrometer. Although all of the atoms of a given element must contain the same number of protons, the number of neutrons may vary. These types of atoms, or forms of atoms, are called isotopes. Isotopes are atoms of the same element that have different number of neutrons and hence have different mass numbers. Individual atoms are far too small to be weighed on a balance. However, as you will soon see, it is possible to determine quite accurately the relative masses of different atoms. Indeed, it is possible to go a step further and calculate the actual masses of these tiny building blocks of matter. Relative masses of atoms of different elements are expressed in terms of their atomic masses. Often, this is referred to as atomic weights. The atomic mass of an element indicates how heavy, on average, one atom of that element is compared with an atom of a different element. On the periodic table of elements, you will find the atomic masses listed for each element. To begin with, convert the percentages to a decimal number and multiply the mass of each isotope by its decimal abundancy. Add these masses together and you have your atomic mass.